Welcome to Geek Do-It-Yourself Mechanic. The purpose of this video is to discuss the variety of scan tool features and functionality so that perhaps you'll be able to choose the best scan tool for yourself based on your level and your end goals. So let's begin by going to the scan tool area. So it's under Knowledge, Tools and Equipment, and we'll go to Scan Tool Features to start off. A scan tool is used to access information from the computer. You'll have a female DTC, Diagnostic Trouble Code connector, under your driver's side dashboard. Your scan tool will plug into that, and we'll go over the different functionality, and the scan tool will then communicate with the onboard ECU, PCM, or whatever they call it for your automobile. This video will concentrate on 96 and newer vehicles. That's because we're concentrating on OBD2 standard. So at a high level, that's what a scan tool allows you to do. Let's go a little more into detail. So the scan tool will allow you to pull diagnostic trouble codes and the associated freeze frame data for that trouble code. The freeze frame data is the certain runtime information at the time that that DTC was triggered. Maybe it'll tell you engine load, engine temperature, things like that. And then once you get that code, let's say P0171, which is a lean code, you can go to a decoder, or the scan tool can have information about that DTC. Right here I'll show you the one that's implemented on this site. Let's pretend you pulled up a P0171. And as I get more and more videos, find more and more videos, I will associate them to more and more of the potential trouble codes that you can receive. Let's navigate back to the scan tool section. Okay, so back to DTCs. What you have to be aware of is that the OBD2 standard specifies a subset, constant set of trouble codes that all manufacturers sold in the US must meet. So when you have a lean code, all manufacturers, all makes and models from 96 to current will show a P0171. In addition, there will be associated generic parameters as well. Parameters, like engine load, throttle position, things like that. Those are PIDs, parameter IDs. So the OBD2 has a subset that all cars sold in the US must support. The scan tool will be able to pull that information out and display it. In addition to that, each manufacturer, maybe even a make model, can have its own specific PIDs. They may have a special feature that the generic doesn't have, so they would have it. They would need to display it and support it to allow their techs to work on their vehicles. So in summary, the OBD2 standard has a generic set of trouble codes, freeze frame data, and PIDs. In addition, manufacturers can have their own set of PIDs and parameter IDs. The next thing a scan tool can do is clear diagnostic trouble codes. Now again, this whole site and all the resources listed on the site all have the same goal in mind, to truly fix the issue. So why would they have that? Well, some trouble codes when you fix the root cause, they'll clear up. Other codes, I believe some of the ABS type codes, you must fix the root cause, clear the code, and then if the issue is truly resolved, the code won't reappear. So that's why they need to be able to clear it. The next feature is a bidirectional control. That's for the intermediate, advanced, professional to use. What that does is allow you to send commands to the computer. Up to now, we've been pulling information. So if we go to this diagram, when you're on your scan tool down here, you'll actually be able to send the command up to the PCM to do something. Why would we want that? Well, let's pretend we're going to see if the idle air control valve is working, an actuator, right? Well, we need to be able to move the pintle in there. So some manufacturers may implement a functional test that allow you to bidirectionally communicate to that actuator, in this case the idle air control valve, to move it. And part of the test would be you would change its percentage and watch the RPM gauge to make sure it changes appropriately and doesn't stick. It's a nice smooth transition, things like that. So that's what bidirectional control is used for. Lastly, with the big demand for many users now that wanting to access the onboard computer, there's numerous ways to connect to the vehicle, one could say. We'll go over that in a second, and numerous platforms. So let's go into that. So there are some where you will always connect into the DTC female connector on the car. From there is where all the variety comes up. Some are a little Bluetooth transmitter that talks to your mobile device, tablet, iPhone, Android phone. Others are hardwired. I prefer the hardwired. And then from there, they can go right to a handheld scan tool. They can also plug into a desktop or laptop, and some high-end professional quality tools plugs into a reader transmitter that then uses a higher bandwidth to communicate to the scan tool. So they can be under the car, let's say, when you're doing your bidirectional test. Sometimes you need to be at the rear of the car to, let's say, turn on the fuel pump to run your tests. So you don't want a cable, they have that. I don't do that. I just have a long cable myself. In addition, what we're saying by platforms is the capability of the device running the scan tool software. Well, what that means is the platform, it has a CPU, how much memory, storage, and graphics. So the more those capabilities are, the more the software can do. Here's one such example. So here's a PID, actually two PIDs, speed and intake air temperature. And if you notice, this is graphed textually. That doesn't take much demand on the CPU. It's not those, especially those, they don't change much, and they're textually. Well, let's look at the one below, air fuel sensor graphically. Well, this is actually graphing the value over time. Some sensors you will want to graph over time. Others, like the intake air temperature, aren't going to change a whole lot, so it's okay if they're displayed to you textually. Well, this particular one here, we're talking at the air fuel sensor here, this is an actual test result where you're at idle and you snap the wide open throttle and you let it go. So in this particular case, the air fuel sensor went rich, went down, let go of the snap, it compensates, goes lean, and then settles back in to 14.7 to 1. And in this case, looking at the manuals, this sensor passed. So in other words, some tests require you to do things graphically. Others, you'll use an O-scope along with the graphical representation. Let's go on to levels now. Here are some examples of scan tools, just pictorially. So this right here would be a Bluetooth type transmitter. This would be a handheld. This is a more advanced handheld. How can you tell? The screen is bigger. Probably does support graphing, where this you can tell is probably only textual. Auto tap, that's a PC oriented display. So this adapter would plug into the female DTC port of the car, plug into your laptop or desktop via USB, and then the software would run on the desktop or laptop and provide really cool graphing functionality, logging, all sorts of things. And then here's a handheld, but it's a very advanced handheld. This is a Snap-on Veros. And what that is, it's a scan tool and an O-scope put together. We'll cover that in just a moment. So let's go over the levels. Consumer maybe just wants to pull the scan, the DTC codes to know what the garage may tell them. Maybe they'll contact you and say, hey, I'm getting a 171, what could be the possibilities? They don't want you to fix it because maybe you're far away, or they don't want to bother you, or they're under warranty. So you could tell them what the issue is. But all these other levels here are people who want to resolve issues themselves. They want to get under that hood. They want to find root cause and fix it correctly. But it could be by experience or how much time they want to spend on the particular issue. So as you go to the right, you become more advanced. You can handle more complex issues, and you have a greater understanding of all the subsystems and how they all function in the car. So you have from novice to professional. Clearly, the professional's goal is to determine the issue as soon as possible and accurately, and only fix what needs to be fixed. That way they can get the car in and out, make their customers happy, and they can make the most money. So now let's translate those levels to the features. So again, if you remember, we're just displaying generic PIDs. Remember, those are parameter IDs specified by the OBD2 standard that all the US cars must support. So that's probably just what the consumer would want. The do-it-yourselfer, they all want that. Then there's displaying the specific manufacturer PIDs and even DTCs. Consumer may not, because that's going to be advanced and they may not know how to even handle that. Whereas a do-it-yourselfer at any level to the professional will want that. Graphing generic data. Now that's definitely when you start needing to debug the car. There's many tests, again, if you remember, that you need to view the data as it changes to verify your test works or doesn't work. So there's where you can display a generic and manufacturer. If you remember, clearing trouble codes, definitely if you do it yourself, you're going to need that. Bidirectional control, that's from the intermediate on up. As you move up, the intermediate may do some of the actuators. The advanced and professional will have the knowledge and ability to work on every actuator in a car. O-scope. Why would an O-scope be built into a scan tool? I thought we were talking about scan tools. And if you remember, the Veris up here is an O-scope and a scan tool put together. If you remember, I said I'd get back to that. What this allows you to do, let's pretend you're having an issue with your mass air meter. The PID is displaying one value or graphing one value, but you want to know what's actually being output by that sensor, because you don't know if it's a wiring issue or an actual sensor issue. So you may hook up an O-scope, back probe the sensor, run the test, see what the O-scope, in other words, what the sensor is outputting and what the ECU is displaying, to see if they match. they don't, maybe there's a wiring issue. If they match, maybe it's a sensor issue. So that's why you'd want to combine it. It reduces the overall pieces of equipment you need, and it also have, especially since it's a snap-on, it's going to have built-in test descriptions and expected results. So let's go on to the next two. A professional, if you remember, they want to get in and out, identify the exact issue. Well, what they do is they subscribe to up-to-date testing information and trouble code fixes. So let's go over the testing information. What they'll have is they'll have pinouts, what the expected waveforms are, and tests for that specific year, make, model. So they may work on a variety of cars, so there's no way you know all the sensors and how all the cars should behave. For example, like throttle position. Many cars are close to zero, some are at 10, 20%. I've seen some at 35%, and that's okay. Well, how do you know that? When you plug into a car, how do you know that? Well, a professional, this saves them time. They look at that and they see the range, they're like, oh, that's okay, and they move on. Again, their whole goal is to get in and out of a vehicle accurately, precisely. Trouble code fixes. As you know, a trouble code points you in a specific area to look. What this does is this maps the probability for your year, make, model to that trouble code of systems that other mechanics had to fix. So what it does is it reduces your overall list of areas you need to fix, because they give you sort of a probability that if you get this code, it's probably in these areas. EGR valve, passage, solenoid. It saves you time versus looking at another component or other subsystems in a car. So again, that's why the professional would want that feature. Well, I've covered all of the topics and areas I feel that you would need to make a good quality decision on what you're going to do. What I suggest is I bought a little bigger than I needed. Why? Because it allowed me to access more information. I bought a scan tool that allowed me for a year to have sensor testing information and specific trouble code fixes. So I let all my friends know that, and when they had issues, they would call me and I would help them out. I would then periodically read through their literature to learn the tips and tricks and upcoming technologies and new sensors and new techniques cars are using. That's just what I did. I had to pay a hefty price for that, but for me it was worthwhile because I wanted to learn and be effective. You don't have that, I'm just giving you an option. For example, I believe AutoTop and some other, even some O-scope manufacturers, like Picoscope, once you're one of their clients, you have access now to their forums, which are very high quality forums. They're not like the normal free forums where people just tell you to switch out parts. They will give you waveforms and strong suggestions. So a lot of times those professional resources are well worth it. But it may be hard to justify if you have one car or two cars and you're not helping your friends. It's just for you. Again, that's your decision, but just letting you know. And sometimes these can be hundreds of dollars to $1,000 a year to keep up to date. So you just need to figure out what works for you. Others are free when you purchase the product, or even a small monthly charge. Again, it's wherever you want to be and how much you want to learn. For me, I have to take care of my car, my children's cars, and friends who come over. So I enjoy working on cars, so I was willing to purchase a little higher scan tool to allow me to grow into it, and I know I can cover more cars, get help when needed. Well, I tried to cover everything you would need to make a decision and learn about scan tools. I thought I would cover this information because when I was purchasing a scan tool, if I would have been given this information, I would be able to know when looking at the shelf, because you'll see a big variety. You're like, well, why is this $50 and why is this one $5,000. I don't get it. Well, now you can understand what you're paying for. You get what you pay for. You got to remember, let's say between these two, the orange here, and again, I'm not trying to bash any manufacturers. I'm just saying, most likely, this tool will have more screen display, faster CPU in it, more memory, so that it can display and help you more. It might even have a database in it to sort of give you ideas what to test, what would cause that issue. So you do get what you pay for, but to know what you need to know where you want to be in this matrix and buy accordingly. This concludes this video. Thank you for watching. I hope you found the information helpful.